Let's get started with those two. What is machine learning and what is AI?
Okay, I'll take it. So the term AI dates back to the 1950s when it was coined by researchers who wanted to figure out how they could make machines that were intelligent. And eventually people figured out that it's very difficult to explicitly program intelligence, and that a much better idea is if you can get machines to learn. In particular, learn from data, since that's what machines process, that's what machines understand. So machine learning is an outgrowth of artificial intelligence, which concerns itself with systems that change in response to data, generally.
I would call, just in terms of terminology, I would say machine learning is a subfield of artificial intelligence.
Yes.
There are other fields of research in AI, and machine learning is a particular one. Probably the most well-developed one.
I think the thing that we hear about in the news a lot is the term AI. So I do like to call it just fancy matrix multiplication. You might disagree with it, but it does seem a lot of times like we are just turning knobs. But there's a science to it, and so I think that's where kind of the discipline, science, data science comes into play.
Okay.
I actually want to say something.
Okay, sure.
So, I was actually very interested in this topic, so I actually read a few blogs about it. So, it is true that like machine learning is a subset of AI, but like some people are now still drawing the line between the two. So some people are saying that AI is something that augments your knowledge from your data, like, and machine learning is something that like you already know what the answer is, but you just want the machine to learn it. Like for example, like image classification. You look at the cat, you know what there's a cat, but you know you want machine to do that fast. So people call that more of machine learning. And artificial intelligence is something like you don't know the answer necessarily. Like you don't know what the stock price is going to be tomorrow, but you employ some algorithms that learns from the previous trends and tells you what the answer could be, but you don't know what the answer is. But you just kind of use the algorithms to kind of get the best guess of it. Kind of. So,
To expand a little bit, though, what you're describing machine learning, where you know the answer or the label to use the term, or label or target are terms used. Specifically, supervised, what's called supervised machine learning.
yeah.
There are sort of other broad categories of it.
A lot of categories.
Yeah.
And we'll get into those if anybody wants to.
My shirt makes a joke on one such.
I think it's
One
important
such
to like illustrate that companies have always tried to do predictions, and so a lot of what we're trying to do is actually just apply newer techniques to this type of work, specifically in deep learning, and that involves totally different infrastructure, totally different compute that you need in GPUs, and that's a lot of the work that we're doing here is our knowledge on kind of building these infrastructures. We're doing totally different types of classification, usually with lots of, the data is much bigger, so you have to have a lot more consideration when building the infrastructure.
These are really open-ended questions.
Yeah.
There's a lot of valid answers.
So I guess a good follow-up question to that would be, could you tell us maybe about examples or applications that you've seen of either AI or machine learning that would maybe help us understand that better?
Okay, sure. Take for instance the problem of object recognition. So you have an image, and an image is a bunch of pixels, right? And there can be different objects represented in those images, like humans or animals, and people ask themselves, how can we get an algorithm to recognize an object in an image? It's a really hard problem because the number of ways that a cat can represent itself in pixels in an array of pixels is vastly more than there are atoms in the universe, right? So you need some way to handle that combinatorial explosion of possibilities. So it turns out it's, the answer wasn't obvious from the outset, but it turns out there's a certain kind of a neural network that solves this problem really well. And the way it does it is you have a lot of labeled examples of the things you want to recognize, and over time, you change the structure of this algorithm so that it becomes better and better at making correct predictions. So generally, to come back to your question, we use machine learning when we don't know how to explicitly code the solution to the problem, but there are examples that we can look at, labels, if you will, that you can use to train an algorithm. So you don't explicitly know how to do it, but you know it's possible in principle, so you can set up a system that will learn from examples how something works. There's a whole other class of problems that can be solved with something called reinforcement learning. So you might not have labeled examples, but for instance, if you look at a game like chess or Go, at the end of the game you know who won and who lost. So you can go back and look through at what the moves were and try to associate which moves led to good outcomes and which moves led to bad outcomes. So generally we use it when we don't know how to explicitly code a solution.
Is there any other example that you would like to share?
I think there's some really neat examples going on in the creative space right now, actually, where we get machines to produce art, which is a thing that seems so counterintuitive, that you can take human creativity and turn it into this encoding that a computer can also represent. And so machine learning is being applied right now to image generation for creating new artwork, to music to generate songs, and to words to generate poetry. So I think that's actually where it's blowing up right now as well.
How do you actually use machine learning to generate art and poetry?
Well, there's a few ways. I mean, to take the poetry example, you can find a lot of poems that you really enjoy, and then you can train something called a language model, which learns the structure of the language. So the language model is something that would take as input, say, the first word of the poem that you want to craft, and it will generate the next word. And so it learns from many, many poems patterns in language, so that even though you don't know how your favorite poet does it, there are statistical regularities in their poems that you can exploit to then generate poems in the style of them.
Does it actually generate good poems?
But that's questionable.
That depends.
That's a subjective question.
Yeah.
That depends what points you get to learn from.
Yeah.
I guess I can briefly talk about the astronomy work that I've been working on. So I came into this without knowing much about machine learning. So I kind of wanted a project to kind of work on, and I really like space. And so a few colleagues and I started down the path of actually looking at astronomy problems. And we're like, okay, can we, the question that we asked is basically, can we apply deep learning to this field of astronomy? And so we looked at a ton of problems that astronomers have, and we basically found this telescope in the Chilean desert that basically takes these big surveys of the sky, and the astronomers basically want to look at these images and very quickly figure out if there's any supernovas in the images. And currently, it's a very manual process. They're going to have to look at a lot of images, and there's some naive approaches of basically trying to quickly whittle down all those images to quickly being able to find the supernova, and then they can go back and actually look and study the supernova. And so we basically asked, can we apply kind of a newer technique called convolutional neural nets to this image data to actually help astronomers and get them to speed through kind of the actual finding the supernova images and actually kind of looking and studying the supernovas. And so we basically built a classification model that basically said you run through all the images through your model, and then it spits out, 2 buckets. Either is a supernova or it's not a supernova, and we're able to actually produce, useful results and a better model than it currently existed using kind of this newer technique, and that also allowed us to kind of cut out a lot of the manual process that astronomers had. So, this is kind of applying newer techniques to kind of processes that have always kind of been kind of manual, and it's really exciting to kind of just ask, like, is there application in these different fields? That's a really exciting thing to kind of just think about as kind of data becomes more accessible. I know in the astronomy world especially, there's a huge movement towards open sourcing code and data, and all the telescopes and satellites nowadays are putting their code out online. So if you're interested in exploring that stuff or you want to talk about it, I'm free to answer questions later.
What's the name of your
That's a great question, Danny.
project?
So it was named after a famous library called Word to Vec. The project is called Space to Vec. We recently published our results on our Medium page, so if you want to go and read our research, it's there. And it's basically about the process of how we kind of went through not really knowing much about machine learning and discovering the problem, and also then kind of building the model and learning about it.
Not knowing much about space either.
That is true, yes. We learned a lot.
So that was outside of Dessa, right?
No, that was a Dessa project. So
Okay.
Dessa kind of allows us to work on these projects to kind of build understanding of machine learning and also kind of get involved in it. We're building tools for machine learning people, so we want to understand those problems. We want to feel their pain. So by doing this project, we kind of build that empathy towards what it's like to take a data set and try and understand it, and all the inconsistencies that you get in building pipelines and productionizing it and running models and understanding your model. There's a whole set of things of course, that you learn.
So that's one example from Dessa, but is there any other example that you might be able to share from Dessa? Or maybe from your past research? I mean, if there's nothing, that's okay.
There's
There
a
is.
lot. I mean, we've obviously done quite a number of projects in production, some of which we can't necessarily share in detail. But one example of a project we did early on was for a bank. Was basically at a high level was taking in a very extensive set of customer information, customers being credit card customers, and then building a model that would predict who would be delinquent on credit card payments. So real world, practical, has tangible value for the client. And then further predict who responds to. So if you call a customer you believe who goes delinquent, are they likely to pay, or are they likely not to make a difference? So the model would further do predictions like that.
So were you able to actually make accurate predictions
Yes.
of those?
That was that model was an early client success for us.
To add on to what Mark said, that model and the bank in particular was our flagship project.
Yeah.
And so that was very successful. Some of you are probably being used by the model are being
Yeah, there are people in this room who have been processed by that model.
I think it's over 40%,
Yeah.
30-40% of Canadians.
Hopefully the model predicts nobody is
Yeah.
missing anything for everyone.
And we're very fortunate to have that project, and we did very well on it. And that project was our flagship project, and its success, we generated multi-million dollars in revenue, and its success led to us spinning out of our original innovation lab and becoming our own company.
Okay, so just switching the gears a little bit right now. I have one more question. It's a question I get a lot on my channel. And don't worry, it's not too complicated.
That's a coding question.
So a lot of my subscribers ask me, what are the best ways to learn machine learning and AI? If they're just getting started.
One of the cool things about machine learning, I think, is it's a field that's really grown up in the age of the internet, in sort of this open information age, and so there's it's not that like it's hard to think of something to recommend. It's hard to pick what to recommend. There's so much good material available for free all over the place. So it kind of depends on style, and I'd recommend like trying a few resources out to name. To get.
I'd like to recommend the Fast AI course.
I was gonna.
Yeah. So
Sorry.
in particular, I recommend it to this audience because it targets people who are already coders, and it's very well done. It was developed by a guy named Jeremy Howard and also Rachel Thomas, who are both very interesting and very good teachers. So please check that out.
That was fast.ai.
Fast.ai.
You can also run Fast.ai on top of Google's collaboratory platform. I've actually been recently refactoring the notebooks from the original Fast AI course. So now run on top of Google Collaboratory, which is kind of like Jupyter notebooks in the cloud. Also with GPU computing for free, which is pretty cool. So I've been updating those notebooks so you can run them straight from a GitHub repo. So you can ask me about that afterward as well if you're interested in doing the Fast AI course on top of Collaboratory.
There's also the very famous Coursera Android course, class widely recommended and for a reason. And those two things complement each other because Fast AI is more practical, build things right away. And whereas Android I think is more
Theoretical.
I haven't looked at it in a while, but more foundations. Here's here's the fundamentals of the field. So in general though, pick some resources, dive into them, do their little projects. But then, my other recommendation is early on, just once you sort of have enough of an idea of what machine learning is and what kinds of things can be done, start a project. Like try and do something. Be like, would it be cool if I could do this? And then as our software engineers who did Space to Beck right here, sort of, you learn everything you need to. I think many people in software find that one of the best ways to learn, and I think machine learning is no different in that respect.
You too can be an amateur astronomer. It's not too easy or not too hard. Thinking something that's like super interesting to you and you'll like the cool thing is like there's this learning curve and it's really painful and like it's kind of difficult, right? And so you want to pick something that you'll stick with that like the question is like you'll push through a lot to actually try to figure out that question. And for us it was kind of playing with space and at the very least even if our work resulted in research that didn't really prove anything, we were getting to spend time with space. So that was kind of the way that we did.
I have one more course to recommend, which is an online freely available book called Neural Networks and Deep Learning by a physicist called Michael Nielsen.
Yeah.
Anyway, I just really find his writing is especially clear. It's very, very good at sort of explaining why.
So I would like to actually say I don't have a computer science degree myself. I'm actually a chemical engineer with background. So most of machine learning that I learned is self-taught. I did take some courses in university, but most of it's self-taught. So, all right. So I think chemical is still like far.
It's not engineer the same.
Yeah.
Chemical, math.
Yeah.
And I'm computer
A bunch
engineer.
of physicists here too. So, but the backgrounds vary a lot. So the way I approached it is I first took some courses on statistics because machine learning has its roots in statistics. So you don't have to be expert in statistics, but you just need to know what first moment, second moments are, at least how do you make sense of data. And then from there, then you can start making sense of what machine learning is doing. Because taking these courses in Coursera, Udacity, or stuff they will give you what machine learning is doing, but understand some very niche things. If you don't do statistics, you will struggle. So it's very much smooth path if you go through statistics and then take some machine learning courses. You become very strong machine learning.
There's kind of two paths that people argue for. There's like the top-down approach to learning and the bottom-up approach to learning. The top-down approach is start with practical things first, start with how to do it, and then get into the nitty-gritty of like what is the underlying mathematics. And the bottom-up approach is start with the underlying mathematics and then work your way to the practical stuff. If I had to guess, I would say the top-down approach will work better on average for this audience, but you have to try for yourself and see what works. And top-down approach being like fast.ai, bottom-up approach being like learning statistics and reading the Deep Learning book by Ian Goodfellow or something like that.
Okay, so just to sort of recap, if someone just getting started with machine learning and AI, you recommend fast.ai, Nginx, machine learning course. Was it neural networks and
Yeah, Michael Nielsen's
deep learning?
Neural networks and deep learning.
Right, and learning some statistics. So
and
after
doing
the-
and
yeah.
start a project. Try and do
Right.
something.
So how should
build
people find a good project to work on?
Pick something you care about. Pick a data set related to a domain that you're genuinely interested in. That is all the motivation that you'll need. Pick something that you've always wondered about. There's a lot of open data out there right now, actually, and there's a few databases specifically for looking at data. So I definitely recommend checking out one of those resources and picking a thing that you're really interested in, a domain that you may have expertise in or want to get expertise in.
Great. How do you find those data sets?
There's a couple of websites right now that actually aggregate data sets for machine learning. And they do that as a pedagogical thing, knowing that a lot of people specifically want to be able to take data and get up and running very easily and have a nicely labeled target. There's a couple resources on the web that specifically aggregate those. You can ask us afterward and we'll provide some of the links. But there's a big one that actually recently came out by Google that's aggregating a search for data sets, and that's always a good place to start. It's probably one of the biggest ones.
For many projects, you'll find there isn't a nicely curated data set. If there's like something you want to do or build, then you'll have to
Collect your own data set.
come up with creative ways of building it yourself, whether it's scraping the web or.
I think, and maybe people here would disagree, but like going to, there's a site called Kaggle, which allows people to compete in kind of data science-ish, machine learning-ish competitions, and people post their code. So what was really helpful for me when I was trying to think through how machine learning people thought was actually just walking through the code and actually seeing what kind of questions they're asking. Okay, you have this data, and you want to build a model to predict, housing prices or something. But how did someone actually get from the data to that model? There's a lot of steps that I just didn't really think about until you actually go through how people think in their code. So Kaggle is a place where you can see all these different competitions and also see people post their code and show you how they did it. So you can like take the code and the data and kind of open a collaboratory notebook on Google and kind of get started kind of thinking right away if you want to take that top-down approach.
Back to what Pippin said. Personally, I started with Kaggle competitions. I first learned the basics through Andrew Ng's course, as Mark said, and also some other Stanford courses here and there. But eventually, you only learn so much through videos, through textbooks. You have to actually dive down into the data. And Kaggle provides an excellent playground for you to get started. The data is curated, the problems is well defined, and there's a huge community around to help you and to get you started. Personally, I found that Kaggle competition was very helpful for me to get started, me to get a grasp on me to try to train my own models, try to win some money or do well in the competition. In addition to that, I also participated in a few hackathons, data science related hackathons around Toronto, places in the US. And these places are good for talking to other people who are interested in the field, talking to leaders who are in the field, employees in the field, other machine learning engineers and data scientists in the field, and understanding what they do. And I'd say eventually, Kaggle is excellent, but can only go so far. I think a huge skill that machine learning engineers, if you wanted to go into machine learning in industry, you'd have is working with real life data. Kaggle is not quite real life data, right? It's kind of been dusted, swept, and cleaned up for you. I remember after I did Kaggle competitions, I then try to do a real life problem on a real life data set that was hosted on some servers from across the world, and I had to basically wrangle everything together and set everything up myself. And doing something like that really exposes you to the nitty-gritty parts of what it means to do machine learning in industry. Right? It's not all just about pumping the data into the model. There's a lot of dirty things that you have to do, nitty-gritty things that you do that are essential and you need to know. So I recommend that.
If you're interested in actually working on real life data, a lot of nonprofits actually need people to help out with their data science processes, their data cleaning, because they don't have in-house data science teams. And so a good way to go about getting your hands on real data actually, as well as contributing to Data for Good, is to help out with nonprofits that are working on interesting problems and might need your help. There is a meetup group in Toronto also that runs hackathons, datathons as they call them, every couple of months called Data for Good. And they partner up with nonprofits all around the world, and these nonprofits will actually hand over their actual data and let people help out with cleaning it and prepping it for machine learning. So if you're interested in real world experience, that's a really great place to get started actually.
Also, there's one more last way of learning machine learning, and that is just go out and make friends who are machine learning engineers, and then you will eventually learn from them too.
Great. So those are the questions I had. I think I'm gonna open it up to the floor to see if anyone has questions for them. Anyone?
How long did it take for you guys to get like proficient in the field?
Okay, the question.
Start feeling comfortable.
Ongoing process.
I think I'm just gonna repeat the question just so everyone knows. How long did it take for you to be proficient in the field?
That's an excellent question, Roger. I'll start by sharing a little bit of how I got started in the field, how long it took me. For me, I graduated last May. So I graduated May 2018 from undergraduate. And when people always ask me, how did you get started in machine learning? How did you become a machine learning engineer? They ask me, do you take any courses in university? And I tell them, I've never taken a single machine learning course in university. I've never even taken a single CS or SAS course in university. Right? You don't need to take CS courses. You can just go to CS Hozier. You can learn all your stuff. And so I started in the summer after second year, and I wasn't happy with physics research because of my background in math and physics. And so I started learning about taking an engineering course, reading books, reading texts, just understanding what machine learning is, some of the basic algorithms, and all that. And afterwards, it was a long process of essentially doing projects, Kaggle competitions, working with the University of Toronto data science team, and some of your U of T students, I highly recommend them. Working on projects with some companies, some are for profit, some are not for profit. And eventually, you have to just get your foot into the door. So I got my foot into the door. I was able to land an internship at a innovation lab here called Zero Gravity Labs. And there I was able to do things related to data science and big data, but not quite, right? Because for machine learning, they still prefer someone with more experience. And then afterwards, after I had the internship, I wanted to do data science and machine learning industry. I didn't want to do grad school because I was tired of school. I didn't want to do more school. And so I guess by that point, I think what really helped me the most was doing those projects that you could then put on your resume. whether they can actually show their proficiency. Because you're not going to be exposed to a lot of that stuff when you're in school. I'm sure you can take a machine learning course and you can run a simple model on identifying digits. But that's not very close to what the industry companies really need from you as a machine learning engineer. So it took me about, I'd say, a year or 2 years of doing industry projects to become proficient enough to qualify for entry-level positions. And that's just a rough estimate. Your mileage may vary. But I would say, it's hard to say exact timelines. Perhaps my colleagues can say more about how long it took for them to become experts.
I think you're extremely dedicated from the beginning as well. From birth, like no, I don't know, like that's a. How long does it take to become proficient in anything? Like that's a very.
As soon as you're feeling too comfortable, you're not pushing
Yeah,
yourself
like
enough.
like
so.
I don't like. Do I feel proficient today? I feel like I'm learning all the time. I'm always learning new things. So, yeah.
Yeah, machine learning is a field where people are still trying to figure things out. So don't worry about understanding everything, because once you understand everything, the next day is going to be different.
Yeah, maybe the way to think about it is like time until you feel dangerous with it, in terms of like you can actually produce something that like is novel and is significant. So I think if that's kind of a metric that you can look at, where like you have a question and you can ask that of the data and you can build a model, then you're dangerous, right? You're getting proficiency. You're using a tool that is machine learning or deep learning to actually ask this question.
Alright, I think we're gonna take maybe 1 or 2 more questions.
Why did you choose machine learning? What made you want to do machine learning?
Well, I'll go.
Sorry, could you repeat the question again?
Yes.
Oh, sure. Why did you choose machine learning out of everything?
Well, ever since I was a little kid, I always loved not machine learning, because I was a kid. I didn't know. Since before second year, I didn't know what machine learning was. Ever since I was a kid, I always loved physics. And when I was a kid, my dream was to become the next Stephen Hawking or Richard Feynman. And of course, research is different from what you read in the or what you see on those popular documentaries. and so I thought to myself, what's something that I'm good at and that I can be good at and that uses my skills well, and that's something that I enjoy. I am particularly like machine learning and data science. And when I got into it, I found that it was using a lot of what I really knew from physics. It's about explaining the world in novel ways through explaining physical phenomenon through mathematical algorithms. And the sheer power of machine learning that blew away traditional predictive classical analytics really drew me. And so that's what I really found fascinating about machine learning. And there's a lot of promise in the future, more so than blockchain.
That was a hot take.
One more question?
What languages would you
Oh.
use?
Oh yeah, it's okay. Yeah, go ahead.
What languages would you use starting point for someone who's not in the coding and wants to get into machine learning?
Python.
I think we all agree.
Next.
Next question?
No. So
Oh, wait. Sorry.
the reason why I think it's unique.
Wait, so the question is, what language should you get started with?
All
If
of
you're
it as well.
new to coding? Alright.
And I think the answer is Python for a good reason, and the fact that it has this wonderful, amazing community that's pushing a lot of open source packages and tooling out there, and there's a lot of great community movement towards documenting and talking about these problems and ways of getting into the language very accessibly. So it's not like a super new thing that's kind of poorly documented. There's a lot of community support. There's lots of meetups, there's lots of documentation, lots of videos. So it's very friendly, and it's also a fairly accessible language. And there's a lot of tools that can get you playing with it quite easily, and so that makes it, in terms of getting feedback on like building, spending time building something, there's a lot of that immediate impact and feedback that you get from doing, just getting into it.
I bet you'll agree on this. You should learn more than one language. Right? Would you agree with that? You should learn more. You should not restrict yourself to one language as on your coding journey.
Yeah, but
That's-
Python is good to get started.
Yeah. Python.
I would say one more question. Go ahead.
So as a machine learner, as a machine learning engineer, my bad. What are some of the key things I would assume that you also, I guess, scan through resumes for other candidates and potential things like that. What are some of the key factors you look into aside from, say, projects and educations? What are some of the wow factors that really attracts one resume compared to other resumes for a potential opportunity in the field of machine learning?
Okay, just to repeat the question, what do you look for when you hire a machine learning engineer?
Okay, I guess
Honestly, that's going to vary. If you're talking in general, different people hire machine learning engineers have different needs. A big one for us is real world, sort of actual someone. If you put machine learning models into production, that's a huge one. But sort of sorry. Yeah, but sort of a kind of practical experience as opposed to just personal projects, because there's a lot of challenges that come up when you're actually trying to apply machine learning in industry that may not.
But personal projects still have a lot of value. I think people actually underestimate the value of it. It's worth way more than a certificate from a Coursera course or anything like that. Worth more even than academic courses. I would say if you do a hard project, something that really pushes you, and you write good, clean code that you would be happy to share, and you put it on GitHub and you write a nice summary of that, that will make you stand out more than the average candidate. For sure.
And to add to that, you mentioned wow factors.
Yeah.
In addition to traditional things like experience with projects, I think one thing that we really value, and that's something that I love about Dessa when I was in different here, is their focus on problem solving. And so I guess we haven't explained what Dessa does. Dessa is an AI company that goes into traditional enterprises, think banking, telecommunications, insurance, and we implement an end-to-end machine learning solution that involves discovering the problem, developing a model, and deploying a solution. And one of the most important qualities that we look for machine learning engineers is problem-solving ability. And that's what we orient ourselves towards. And the reason for that is because when you go into client side, you're tackling a pretty new problem. And these problems you won't find much documentation on how these problems have done before in the past. And so you essentially have to figure it out yourself. You have to figure it out. And at the same time, you have to figure out all your data sources, and then figure out all your infrastructure, figure out how to put it to production. And so a lot of new and novel problems that you have to solve when our machine learning engineers are developing these solutions. And so I think problem solving is something that's very important.
Okay, great. I think that's it for the Q&A session. Thank you so much, everyone.